Hey guys, we'll be waiting for 2 more minutes for the community members to join, and then we can start with our fifth OLake community meetup. We have some exciting contributions, exciting features that we have launched in the past couple of. So, stay tuned for more. I can see some new faces around here. Like Sanskar has joined us for the first time. I guess Akash has joined for the first time. Harshvardhan, yeah, as usual, he joins our meetups, and yeah, it's good to have you again. So, if you are not too camera shy or would like to maybe introduce yourself in a couple of sentences, like who you are, where you work, or where do you study, that would be awesome. And how do you get to know about OLake? So that would be awesome.
I'll be first. Hey everyone, I'm Sanskar. I'm currently working as a doctor, and I will be mentoring CFO.
Sanskar, we were not able to hear you clearly. Uh,
Are you able to hear me?
yeah, can you be a little loud? That would be good.
Yeah. I first into the competition. Hey everyone, I'm Sanskar. I'm currently where I plan and planning for launches. This year I would be also mentoring for GSUP project for Python Software Foundation, and I'm one of the mentors for the project on CE2. So really nice to meet you. Sam.
Same. Likewise, we could not hear you for the 50% of the time, but yeah, I could guess you were mentoring some CNCF project, assuming. Uh, yeah.
Alright. Are you able to hear?
Mm,
Just give me a minute.
sure.
My voice is clear.
Yeah, it's clear now.
Yeah, it's all clear to the heights. Hey everyone. So should I go again?
Sure, please do, because we were not able to hear you for the first two times.
Hey everyone, I'm Sanskar. Currently, uh, this year I will be also mentoring for some projects with Python Software Foundation. And one of the details for the project called CE2. So, standard. And yeah, looking forward to that.
Great. It's nice to have you here, Sanskar. Okay, I guess just 1 more minute and we can start with the agenda of this meetup, showing you the demos of the features that we released, how you can just join our community, make some contributions, and the goodies part as well. How you can sync data, like if you have some data, or if you were just checking out our project as a student, or maybe using OLake in some of your use cases. We'll cover all those spaces. Here we have like the other person who I can see on my screen is Shubham. So Shubham, maybe a few lines about you for the people who are new.
Hey, hi everyone. I'm one of the co-founders and CTO here at DataZip. So we are creating the product called OLake, which you all are familiar with. Just keeping it short, I'll hand over quickly back to the Priyaj. So I've been a data engineer myself for last 10 years. I have worked on the pipeline sizes, like a couple of GBs to petabytes. I have worked with many of the big companies in India as well as abroad. So that's a quick introduction about me. Handing it over back to Priyansh. We have a lot of exciting updates for you guys this time.
Sure. I was just opening our OLake UI and the work that's been done, led by Swati. Swati is also on this call. We'll come back to her if she wishes to just show you a quick demo. But let me show you a little about our repository where the front end is being developed. So right now it's not, we have not yet made any changes to the master branch. I'll show you what I mean by that. Is my screen getting shared? Right. So this is the OLake front-end repository. So if you want to check the Figma designs for now, you can see that. Or if you want to see the actual work that's being done, you can check out the front-end initial setup or the staging branch as well. But that's just okay. Okay. I just have to open it in some other browser, I guess. So while that opens, let me show you a quick demo of what are the features that we have launched. So if you go to our docs section, you will find, yeah, we fully support MongoDB, Postgres, and MySQL as sources or connectors. And for destinations, recently, like a few days ago, we were able to merge, yeah, Apache Iceberg as a destination, AWS S3, and local setup. So how you can set it up on your local system, or if you have some setup where you want to send it to maybe cloud or S3 or things like that, everything is there. You can come and check out what is Iceberg, which all catalogs we support, the quick start guide, what all files you need to create, the discover and sync commands. So right now everything is UI based. Sorry, everything is CLI based, and this is where I'll show you, or we'll see how the OLake's UI, or yeah, let me check out the Teams page. Mm. Apologize for my little slow internet connection over here. Yeah. Um,
I'm guessing Figma is too heavy.
yeah, I guess too. Anyways, moving back, let me check. Yeah, we have good amount of audience. We can start the demo. So, mm, mm, great. So, if you want, if you can just go to the writer section, you'll find basically two things: Iceberg and Parquet. If you go inside Iceberg, you'll see we are currently using an open source project and using it, supporting basically our Iceberg writer, the Debian server Iceberg Sync. So inside of it, you'll find the modification that we have done to the project. If someone is curious how these two projects are different, and if you want to test it out locally for yourself, you just need to check out our local test. For this, the readmes are present over here, what you need to do, how to set it up. And if you do not prefer the readmes, it's also in the documentation, which all branches to check out, which all folders to go, and which all, you can say, Docker Compose files to run. Like the README here is maintained by Shubham, so I'll have an improved version of it on the website olake.io. But if you're comfortable with README, that's also fine. There's not much complex setup. It's simple as running a few commands, and your data will be in the Iceberg destination. So first of all, you need to just cd to writers Iceberg local test. We have provided with you a Docker Compose file, and in that Docker Compose file, we have set up Spark Iceberg, so you can query the data after it's being dumped into Iceberg. We have set up a Minio. So Minio basically serves as a local replacement for your S3. So if you don't want to just send data to S3 and want to test it out OLake locally in your system, just install Minio, set up the user and password. It basically kind of mimics the S3 protocols, AWS S3 protocols. And then we have a Minio client over here. and then Postgres. So currently we'll be testing it with JDBC catalog. So if you're not familiar with what is JDBC or what catalogs means, you can just do a quick Google search, or we have also provided you with resources on what these things are, the terminologies of OLake, what we mean by a lake house, or what is snapshot or CDC. So this is basically relevant for the people who are new to this engineering field. But if someone is a seasoned data engineer, he or she should all like would already be knowing about all these things in advance. So this won't be a relevant thing for them. So for that, JDBC catalog will be using Postgres as a database, and then let me go back. Yeah, the normal Iceberg network and the volumes. So with that setup being done, I'll just go back to my, yeah. So I was doing some testing before we started with this call. Okay, let me press exit, and great. So let's follow our documentation just for reference. Going to writers, Apache Iceberg, overview, config, Docker Compose. So in here, we'll first clone the OLake repository, which I've already done. It's present over here. I'm not running this system, setup on my local machine. It's currently hosted on an EC2 instance. So you can do this on your local setup as well, or on cloud as well. Doesn't make much of a sense. It's just better processing that I get with cloud server. So that's why I'm using it. You can clone the repository, start a Docker Compose services. So the Docker Compose file that I just showed here, you have to just run a command and it will be up and running. Okay, someone has joined us, so let me allow the person. Okay, Sayan Das has joined us. So hey Sayan, just we started with a demo of our new features launched at OLake a few minutes back. So you'll have a recording of this session posted on YouTube. So stay tuned for that thing.
Yeah, okay.
Sure. Coming back to the docs. Yeah, for the prerequisites for the setup is that you need to have Maven installed as well as OpenJDK installed if you want to set it up locally. Otherwise, if you want to just send your data to maybe S3, you can use the Glue catalog, and then you won't need any kind of initial or prerequisite setup. So if you go to config over here, you'll find using Glue catalog or using JDBC catalog with Minio. That's a local setup for now. We'll also be supporting in future. Let me go to roadmap and come to catalog. So yeah, REST support will be out in a few days. So you'll be able to test with Nessie, Polaris, Unity, and Gravitino. And if you want that OLake to support Azure or Big Lake Metastore, so just submit as a request and we'll prioritize it depending upon what the community wants. So Glue catalog, it's not work in progress, it's live. Hive Metastore, it's live too. Oh, sorry, it's not live. JDBC catalog is live. Hive Metastore support will be live maybe in a couple of days. We'll post all the updates on the Slack, so just turn on the notifications if that's not already on. So coming back to our Docker Compose, the third step being just make a config.json file. So it will contain the source configurations from where you want to sync the data to Iceberg. Maybe the source can be MySQL, the source can be Postgres or MongoDB. It doesn't really matter. And then you'll have to create one more file, writer.json. And it will contain the configurations like, well, let me show you, it would be better for me. So this is a sample writer.json. The type will be Iceberg. Of course, you're dumping into Iceberg. The catalog type will be JDBC. If it's a REST catalog, you will just write REST over here. The JDBC URLs, usernames, password, the path, admin, and the Iceberg DB. So a brief description of all the fields that we just talked about is present just below it. You can see which all fields are relevant to you. But if you just copy these parameters or these values, it will just be fine for your local setup. So let me just go back over here. I've already created. So for this demo, I'm using MongoDB as my source database. So I've already created config.json. So this uses a localhost 27017 because my MongoDB is also on a Docker Compose file, which I just created for demo purposes, which has some like 27 records, 27 odd records. So if you do not already have a MongoDB instance hosted somewhere, or you do not have the data, or just want to test out how OLake works with a MongoDB replica set, so we have given you a Docker Compose file. It's also available when you go on sources, go to MongoDB, set up replica set. So depending upon if you want to use a Dockerized version of OLake, or you want to build OLake locally, just copy this compose file, just Docker compose up, and you'll have a running Docker MongoDB database instance with replica set and some few test data that we ingest in it. Let me show you the data what you'll be using. So yeah, if you go on to this URL, we have some sample records which will be inserted as a Reddit database, and inside the collection name will be named funny. So it's not a funny collection, but the name is funny, so it's fun to work with. Okay, that was a very bad PJ, but you get the point. So everything is set it up for you. Let me run first. We have the config already. We just need to Docker compose up this file. So I don't waste time setting it up. I have already written the command which I need to use over here. So this is how you can start your MongoDB instance. Yeah, let me just move it over here. Close this view so you have a better view, and let me zoom in a bit. Great. So I press the commands, it will go and find the file inside the MongoDB config docker compose.yaml up -d, run it in detached mode. So when I run, it says created, started, because this process might take maybe 30 seconds for you, but because I already performed it, it took just a couple of seconds, a fraction of a second. So with this being done, I'll just go back and show you my writer or JSON file. So this dumps the data in an Iceberg format using JDBC catalog. But if you want to dump it locally, then you can just have a writer-local setup. It will dump it. Sure. It will dump it on your local machine, and you'll see these kind of Parquet files over here being created. So this demo is for Iceberg, and we'll see the demo of Iceberg. But let me go back and see if, yeah, anyone has any questions about it, or any excitement with the Iceberg writer. I know I'm not the greatest entertainer, but this is a feature that we just launched, and we were excited to tell you about the community, how these things works, and just show you our capabilities and the future roadmaps of what we have planned for roadmap. Okay, I guess there's some lag over here. So for now, I'll quickly close Firefox. So yeah, waiting for any questions, or anyone wants to raise any questions, how this was done, how that was done. The meeting links or the meeting recording will be provided to you as soon as this gets over. Okay, I apologize for, yeah. Can anyone see my screen? Can everyone see my screen? Great, great. Great. So coming back to the setup, in the previous editions of OLake Community Meetups, we have shown you how you can dump the data locally on your system. It will create these Parquet files, but now we'll be dumping to Iceberg because we have the Iceberg support finally with us using the JDBC catalog. So the commands for how you can do, the syncs is also in the docs, the step-by-step explanation, where you can, if you go to the section where you see MongoDB to S3 or Iceberg, you'll find a TLDR, what all things you need to create, the writer file, the config file, run the discover command, run the sync command. So that's the 4 basic steps that you need to perform, and the data will be synced. So uh, sync data. Yes. In order to do your first thing, we need to discover. So discover basically means the kind of data, the kind of schema of your database. So let me show you what I mean actually. And yeah, your stream name or collection name or table name is funny, the namespace or the database name is Reddit. So this contains maybe ID, it's of type string, all awardings, it's of type array. So this is basically just giving you an overview, the schema of a database. So before we sync the data, actually we need to discover what all fields, what all columns are there. And you can also specify the partition column, partition regex. So we did dive deep into what is partitioning regex, how you can set it up in our previous meetings, in our previous setups. So if you want to take a look at how it's done, you can go to AWS S3 under destinations and go to that data partitioning. Everything is written or mentioned over here, the syntax of writing a partition regex and things like that. So we won't be diving that because we have a limited time in this demo. Let me just come back and perform a few commands. So this will basically discover our MongoDB database to give us the schema, what all things it has, the collections, the column names, and the column data types. So just copy this command and paste it over here. Done. So yeah, you'll get this kind of an output on your terminal, and also a file will be automatically created in the same destination where you have created your configs and the writer.json. So you need to just reformat it once. Great. After it's reformatted, you will have a better look at what the streams are. If right now there are just one collection, one stream, if there are more, you'll be able to pick what all streams you want to select. You can just neglect syncing or moving the data or replicating the data into the destination if you have more than one collection. So you have all that option, but because this collection or this database just have one collection, that won't be needed. So after this is done, if you see this, your discover command has performed well. Congratulations. The next thing to do is providing the path of config, providing the catalog, because now we have our catalog with us because we did the discover thing. Now we need to do the syncing part, the actual part where the data gets to the destination, and then the destination path, of course. So this is basically building it from this repository. If you do not want to do that, you can always opt for the Dockerized version of OLake. So where to find that? Just head over to getting started, MongoDB or MySQL or Postgres. It's on you which all database you want to test it out with. And you will see OLake Docker commands and run OLake command locally command. So we are actually using the build commands over here. You can go to OLake Docker, use the source MongoDB or source MySQL commands, MySQL image over here, and it will basically save you locally setting up OLake. So coming back to our setup, copying this and pasting it over here. Okay, so I just did an writer local. I need to do writer only because that will dump the data. As you can see, there were 4 files. Now there are 6 files. Dumping, go back, then. So this is actually our Iceberg writer running live. As you will see, it's performing its compression, decompression, connected. So yeah, total records read 27, shutting down Iceberg server because the sync is complete. So after the sync is complete, you would want to see where my data went, or was the process actually successful or not. So the way to do that is just go to Iceberg docs. We have steps mentioned over here on how you can see the things that happened. Go to config. Okay, it's supposed to be okay. It's supposed to be under Docker Compose. Great. So to verify where the data got populated, you can just exec into the Spark Iceberg. Let me go here, Spark Iceberg, and then start the Spark SQL server. So Spark SQL. So it will take around 15 to 20 seconds to just start it up, and then we'll see the data that's actually got populated. So there is another way of not having to use CLI version, and just you can see the data synced on your local browser. So I'll tell you how to do that. So now when you see Spark SQL and this caret symbol, it means the Spark SQL is running successfully. Now, the name of the table is funny because we mentioned it to be funny. Or in your Docker Compose, you can just change the names to whatever you want. So let me show you first if there are any databases. So show databases. Yeah, so OLake Iceberg was the database being created. You can change the name of it from the Docker Compose file. Then let me show. Okay, let's go back here. Why to type it out when we have the commands? Show tables from OLake Iceberg and .OLake Iceberg. So this two tables, the funny one and OLake test table was being created. So the funny one is actually containing the data of MongoDB, the data that we sync from MongoDB to Iceberg. So let me show you. Yeah, select star from the table name .funn5. Okay, so this is actually the JSON data that's being dumped, but it's not in the readable format, as this doesn't make much of a sense, but the data is there. That's a good thing. So in order to actually visualize it on the UI, you just need to go to a browser, and if you would have used this setup on your local machine, you have to go to localhost uh, 4 times 8. But this setup won't be working for me now because I'm not actually running OLake on my local machine. So for that, you need to input the IP of the machine. So for me, it will be 4, 240, 65, and 100. So just come on here, 420, 65, 100, 4 times 8. And after you press enter, you'll be seeing a Jupyter notebook of a Spark session. So just go to File, click on New Notebook. Then you will be asked to select a kernel. So just go and select Python 3 kernel, press select. So there's actually a little format on how you can run your Spark SQL queries. So this is actually the format that I just did ran before this meetup to make sure there's no hiccups. So let me go back. Select star from OLake underscore iceberg, OLake iceberg, and funny. That's the exact same command that we used to see the data being populated in the CLI version. So I'll do that again. Okay, let me do and run. So if it's your first time, it will just give you little warnings. But yeah, great. So this is the 27 records that were synced. It will have OLake ID and the data that was actually being populated. So right now we have not normalized this. It's a dump of data that's present over here. So what I mean by that is, yeah. So in this settings, if the normalization is turned false, we'll just dump all the data that we get, especially because MongoDB has a key sorry, key value pair database data systems. So if that is turned false, we'll just dump all the data in a data column. But if it's meant to be true, so if you might have seen in our earlier OLake community meetups, I did show you, you'll see a lot of columns for like yeah, author flair, rich text is also a column, author flair text is also a column. So that's how you can normalize or flatten this complete JSON dump. So that's how you can see your data being dumped from a database, in this case MongoDB, to Apache Iceberg. So let me come back to see if anyone has any question, because this feature took like good amount of our team's effort, and after it got merged, everyone was happy that yes, this was what we set out to achieve. And we don't have actually the benchmarks to show, like official benchmarks to post and you can verify it for yourself, but our team did an internal testing and we can say we were around 2 to 3 times faster than the existing solutions that you can use. I won't be able to speak much on the exact benchmarks and how do we compare, but just keep on looking at OLake.io and you'll see a section inside Apache Iceberg showcasing our benchmarks with proper proofs and what we did, how much times we are faster than that. In terms of the database sources, MongoDB, Postgres, and MySQL. So for MongoDB, the benchmarks are already out. For Postgres and MySQL, just hang on for a few days. We'll be posting them, but I can give you a sneak peek that around it takes 1 hour to sync maybe 100 sorry 10 minutes to sync maybe 100 GBs of data from a source to destination, with at max being 1 lakh records per second. So if you're not sure what I mean by that, you can just check out or cross reference MongoDB benchmarks and see the incremental sync times, the record per second, what is the industry standard, and how much were we able to achieve with OLake. So it can go up and down, but just wait for the official benchmark to come out and we'll have a better solid proof to back our results. So with that, I would like to just pause for a while. Okay, one more update that I would like to show you. So if you go to OLake GitHub repository, we have started a discussion on basically asking the community on what you would like to see us making more in the future. So this is basically a discussion for the OLake roadmap, the things that we have planned for the Q2 and Q3 of 2025. We would like to also make connectors for S3 and Kafka and MSK. So if Rohan is in this call, if you would like to just enrich our community members with what all things we have planned ahead in just maybe 2 lines. So Rohan.
Hey, good to see everybody here. Just a couple of lines on like what's coming up. Of course, improvements on whatever we have shown today is definitely in the pipeline. Benchmarks will be out soon as well. Key big features that is planned in next 2 quarters, particularly is you might see more connectors coming in, specifically around S3, Kafka, or MSSQL. Other than that, there's entire thought process around integrations with other orchestration tools like integration with Airflow, Daxter, or maybe other tools like dbt and all. So that's one thought process as well. Uh, Not sure like if everybody was here in the initial part of the call, but you got a sneak peek towards the GUI functionality of this as well. That is also something that we have been working a lot towards. Look for it is still, I would say, like 3 to 4 weeks away from being out, but yeah, excited to get that out as well. And yeah, a lot of more things. Of course, so the purpose of doing this in community is to get your ideas as well. Whatever, if somebody have any particular requests, if somebody has any particular thoughts around the roadmap, we'll be happy to have a quick discussion and work it out. Thank you. Any particular questions, like since I'm unmuted myself already right now, any particular questions, anything, any thoughts? Amazing. Yeah, thanks.
Well, before we wrap it up, I'll just have a few more updates to share regarding. Let me show you before I tell you what I mean. So, assuming that my screen is visible, yeah, it's visible, I guess. So yeah, we just started to maybe have some stickers. So if you can see my screen, these are some stickers I already have in my hand, some more stickers and some more stickers. So the chair that I'm wearing right now is also something that you can have if you wish to just contribute to us, maybe in your free time or maybe as a hobby thing. So you can go to issues OLake, that is Inc. OLake issues, and just filter it by good first issues. Yeah, good first issues. So you'll see a couple of issues like Postgres inconsistency in CDC and backfill data types, fails on UUID type, and the bug, the beginner tags. So if anyone's interested, feel free to just reach out to us on how to do that. But we also have guides in our website on how to make pull request, how to report a bug, the steps, how to modify a source, which branch we are taking the contributions on, how to get your PRs. Maybe like, let me show you the one common thing or one common issue that we see with our community folks is yeah, the commits were somehow not signed. So I would request all of you to please just give it once a read on how to contribute to OLake, the steps, which issues you need to pick up, how an issue is getting assigned to you, how to work on that. And for any other questions, just Slack is always at your fingerprint. You know me, and you can just ping to Ankit or Shubham as well. They'll help you out which all things you need to pick up, or how the actual issue, or if you see that this issue lacks some description or you are not sure what this means, just comment down below, like, please assign me this issue, or can you please explain me a bit on the things that need to be done here. So yeah, that would be an awesome thing to do. The last thing is the recording of this video will be present on OLake YouTube channel, like how we have given you fourth community meetup, third community edition. There will be a fifth edition as well, in case you were not able to see or miss out on any steps, or maybe not able to follow. But yeah, those things will be provided to you. And I did not show you the demo for the newly launched MySQL and Postgres. So there'll be sample videos on our YouTube channel on how you can sync from Postgres to Iceberg, Postgres to S3, MySQL to Iceberg, MySQL to Post3 in a couple of days. So small feature videos of things to do from point A to point B, how to utilize that feature, or maybe how to build OLake's Docker image yourself. So right now you just need to go to Docker file and change some things over here. So the documentation is not really out, but it will be out in 1 to 2 days. So you can do that as well, because testing the entire flow will take you some time. So with that being said, let me pause my screen. So yeah, Shubham has something to say. He's raised his hand. So please, Shubham, the floor is yours.
Hey, thanks. Thanks, Priyansh. Thanks for the quick walkthrough around the new features that we have launched. So for the folks who are here for the first time, or the people who are existingly contributing or testing the product out, we have a couple of, like, I'll quickly present a quick architecture for you folks, right? So that we understand how OLake as a kind of a simple application which syncs the data from different databases or sources works, right? A quick architecture here is, so we have our databases like Postgres, like Postgres is one of the popular ones. Then like databases like Postgres, MongoDB, they are not really good at analytics. So we dump the data from Postgres using OLake into, like a data lake house. Lake house is basically Apache Iceberg. So Apache Iceberg is a data lake or lake house which stores the data into S3 and uses some catalog in order for it to control the writes, so that no concurrent write happens, and for many other things, right, to store the metadata and all. So catalog can be something like a database like JDBC, or something like which is a managed service like AWS Glue, or something which can be as simple as basic like a Hive Metastore or something, right? So there are multiple types of different catalogs. So we use OLake. You have to provide the catalog detail and the S3 credentials or S3 details in the OLake configuration, and then you can basically sync first the full data from Postgres to the data lakehouse using like a full, like a backfill kind of a thing. It will automatically configure the backfill for you. And then you can, after the first full load is done, all the data from certain tables is synced to the data lakehouse. You can then sync it incrementally using a functionality called CDC. I'm pretty sure like most of the people here are aware of CDC, but for the new folks, it's a change data capture. So whatever the data after the first full load is changed, then we sync that data using a functionality called change data capture. We capture the data which is changed and then sync it to the Iceberg. Now, Iceberg, what is the difference between an Iceberg and a Parquet? Basic Parquet is Iceberg has really good functionalities around like upserts, right? In a basic Parquet, when you ingest the data, it creates it as a duplicate copy. It will just keep on appending. But in the Iceberg, whenever you insert the data or ingest the data, it basically deduplicates the data, or kind of you can say like it will keep the latest copy of the data on the top. So imagine if you have a user ID user table, and then you have a user ID, let's say 123, and in that 123 user ID you have just changed your address as a column, right? So you when you select star from that table in your lakehouse, you would only want to see the latest row which has the latest address of that. You don't want to see two user IDs with 123 123. So that's what Iceberg or data lakehouse offers. And then there are different tools like Athena and Spark, like Athena, Trino, or even Spark. You can actually query this data which is present in your data lakehouse. So that's a really basic architecture. This is how really basic data engineering pipelines look like. Like we have just published MySQL, Postgres, MongoDB, and OLake support for Iceberg writer. Like this is written in primarily Golang, but also some level of Java is there, because the Iceberg is actually primarily has a support for Java. But we are soon going to add a lot of improvements in the Iceberg part of the writer. We'll be deciding to move to either Rust or Go, so that the performance increases. Java has its own performance issues, right? So this is a basic architecture look like. Would be happy whenever Priyansh launches the docs for the Postgres and all. Would be happy to see more contributions or more testers of the platform. And if you are a working professional, you can try this out in your own company. If you are a student, you can basically just check out our Slack channel or the contribution and documentation, so you can learn on what Iceberg and what sort of OLake as a project does, and you can contribute, right? So that's a basic quick architecture walkthrough from my side. Happy to take any questions, any doubts.
Hey Subham, I have a question regarding the writer side. I mean, at my previous company, what we were doing is, so we already had this CDC pipeline. We were using Debezium. Through Debezium, it goes to Kafka, and then there was a Spark job which was writing to your object storage. So in your case, like in case of OLake, like how the writer thing is working, like are you writing new files every time, or like it is modifying the same file again and again if there is a change in same particular record, or like how compaction works? I mean, is there any kind of process?
Understood. Got your question. Thanks for the question, Akash. So basically, whenever you're writing to a data lakehouse, right, almost every write happens on a newer files itself, but there are some modes to write, which is called COW and MOR. So in
Yeah.
COW, you use the Spark, and then you on the fly, whenever you're writing to these new files, you basically combine the data into old file and the new file into just one new file. Right. So that's what COW does. MOR, it primarily just writes the data into the new files, and then eventually, like MOR, once the read happens, like at that point, or whenever in the some level, let's say future point, it basically compacts the data for you, and that's what's called MOR, like merge on read. So whenever you read or you perform a compaction, it will basically merge the data. So right now, in OLake, we are using Iceberg version V2. In this version V2, you can actually write data into MOR without using Spark, right? And that the functionality is called equality deletes. So there are two types of MORs as well. One is a positional delete and one is a equality delete. Right now we are using equality delete because we are like having a CDC as our kind of a source, right? And CDC gets a lot of data, like really quickly. And if you want to see the data really fast to the lakehouse, you cannot wait for the Spark to process it, because Spark is a little bit slower as a process, right? So what we do is we use equality delete, and we directly write it to a new Parquet file, which has a ID for its deduplication with the previous data. right? And what happens is whenever you run a compaction, it will basically compact the old file generated and the new files that are my smaller files with the older bigger files like that.
Got it. Yeah. Cool.
Yeah, I mean, Priyansh has written a great blog around it, so you can definitely check it out like this long.
Sorry to interrupt you, Shubham. It was not written by me. It was written by one other teammate. So I think we
Sorry,
had
I just published this. It was written by someone else.
like, the doubt is justified because most of the blogs you'll see on OLake.io is written by somewhat me. So uh, great. So any other questions by any other community members? Like Harshvardhan asked about the signing commit thing. So we are just thinking about it, how we can maybe in just help you get the commits verified, or just remove this barrier completely. So you'll have a better clarity on it. Just keep looking at the docs, or in the comment section where you comment that you want to pick up this issue. We'll clarify to you that this requirement is strict or this requirement is not needed for now. Great. Okay, Akash has just sure.
Yeah. So I have one more question. So in case of CDC, let's say, so I mean, working mostly through Postgres CDC. So how frequently you capture changes through OLake? Like, is it kind of streaming, or like you look for changes in batches in the, I mean, Postgres, and then stream it and then write it? Like how it's.
So as of now, like just to basically tell you, like the way it works is it's a CLI based thing as of now. Like the whole OLake as it's a CLI project, right? So you can run it continuously. The CLI, like you can basically just keep on triggering it using a cron job or something like every minute or so. And in the future, when the UI part is developed, we'll also have an orchestration support via temporal, right? So you can also schedule the things like that. But to answer your question specifically, right, on how the way, like, do we do streaming or do we do batching? So right now we are doing like somewhere in between. So what does that mean is, let's say you have a CDC, which is like a, let's say, write ahead log, right? It writes all the things into like a append only file, right? So like what we perform is kind of a continuous processing. Like it's not exactly a batching, it's a continuous process, and it's not exactly a streaming as well. So what happens is we will read, like example, we have read the wall till like 0.90, and then whatever comes after 90, let's say 90 to 110, we'll read that once the next process start. So we are introducing this mode of continuous reading, where it's kind of like if it first reads the data and then figures out, okay, now the latest batch is 110, so it will read those 20 records, dump it, then again it will start quickly. After 110, it will read to whatever the next wall that has come, right? So this is the way we are basically we are planning this. This you can easily achieve like somewhere like 10 to 20 seconds of sync latency, which is really good enough for a data lake house, I would say. But again, that depends a lot on, because this kind of latency is really also will give you a little bit good amount of cost for compaction, because there would be too many smaller files. But again, we are also creating some solution for compaction, maybe in couple of like 1 or 2 quarters ahead. So like we can also like talk about this at a little later point in time. But as of now, like you should only do this kind of continuous processing, or basically kind of streaming, if you really want to get the data into like less than minute worth of a latency, because it has to justify the use case. If you just sync tables, it will be really expensive for you.
Yeah. Got it.
Yep. So I mean, like if you guys are interested, I can quickly give you a demo of Postgres as a source, if you want. But yeah, Rohan, like, do you want to ask something?
Yeah, I just wanted to point out that community members have already picked up incremental for MongoDB. So just wanted to like call it out. Really excited for that. And I think Akash, with respect to your question, like continuous streaming or continuous process versus kind of like a interval batch process. Once we have incremental, this will get better as well.
Got it. Thank you.
I think we can, I mean, like at the end, I can show you a quick Postgres demo if you guys are interested. So people who are interested, they can just stay on the call. I'll be just walking you through a basic Postgres demo. Priyansh, do you have any more things?
No, Shubham, that will be all. Like, those are all the updates.
Cool. I'll quickly just start with my demo. It will just take like a 5 minutes time. But yeah, it's a really interesting one if you guys use Postgres in your day-to-day lives. Hope you can see my screen, right? Let me also open a browser quickly. So I think I'm running my Spark, like a test Spark that Priyansh just mentioned, that you can do a Docker compose up and that will spin up a test Spark so that you can query the lakehouse. That's already running. Let me quickly open any of the notebooks and just do a SQL. So I have a table named Wishlink test, right? This is one of the tables. As of now, I think this table is most likely not present because I have not synced my data yet, right? This is not present in the Spark. So let me quickly also show you folks a bit of the data, right? So this is my table, which is called Wishlink test 5. And if I run this query, it should show me, just a second. So this is the data in the Postgres. Like this has like multiple different types of columns, and these are the IDs. So now what I'll do is I'll quickly sync this table. So what I'm assuming here is I have already run the I have already sort of run the catalog or discover command, and I have added these 4 to 5 tables in my. I have just selected these 4 to 5 tables in my catalog. This database has probably more than 100 tables, right? So I have just selected these 5, and there is a Wishlink test 5 as a table. So I'll just quickly sync. This is how the sync command looks like. I just ran it before some time back, right? So I'm just quickly gonna run it. So now this has triggered this whole flow where it has 5 tables in the Postgres, and it's basically syncing now all of these tables first as a full load, because as of now I have not passed the state variable in the CLI. So it's assumed that there is no sync that has run before, and it's just going to run the first full load there. And also it will, while the full load is happening, it will also wait for all the CD. It will mark the CDC cursor. And once the full load is done, it will again fetch all the records which came while during the full load, because your database will not sit idle, right? It will continuously keep on getting records. So just to check, yeah, I think the sync is done. We have synced 26 records, and let me quickly go to the browser once, right? If I try to run the same command again, I think I have just typed Wishlink test, and I can also type like Wishlink test 5. So as you guys can see, like the data that you are seeing here, it has just came to your data, lakehouse. Right now, it's not a normalized thing. I have turned off the normalization in my writer setup. I have turned off the normalization here false. So that's why you're able to see like a JSON data. But if I take this and if I put it over here, so you should be able to see like the same data that I was just seeing in my Postgres, right? Now, again, like for the sake of CDC kind of a demo, what I'll do is I'll go ahead and I'll modify this ID with 3000400 with some level of text like testing OLake, right? And I'm gonna save this. And now I'll just go back quickly and I'll just sync the data again, and I'll also pass the state this time. So whenever you do a first full load without like a sync without passing the state, it will create a state file and it will mark the cursor, CDC cursors over there. And now if I pass the same state file over here, it's just going to sync the incremental records which came after after I sync I've done the first sync, right? So let us trigger this one. Ideally, it should just sync like one record or a couple of more if somebody, while I'm demoing, they have inserted into the 5 tables that I'm demoing with. So it will just take a while. So while this gets finished, what I can definitely yeah. So I think it finished really fast. It synced like one record as of now, and if I go here, I basically I modified this ID. So give me a sec. I guess my Postgres. Yeah. So if I go back here and I search for this ID 3300400. Right, here is this ID. Right now, this will show you as the timestamp as 1970, which is the start of the time, because this row is being read as a part of the full load or the full sync, right? But if I just run this command again, yeah, now you can see the same row, which is ID 3000400, which got updated as an operation type. And I think the short URL ID, which the column that we updated, it has changed to the testing OLake, right? And the same record now, you can also see the time, which is recently the UTC time that I have updated onto. So this is how the basic of OLake Iceberg writer works from the Postgres or from any of the databases that you would want to sync. Happy to take any questions, any doubts, or any recommendations. You can mention it on the channel, like the Slack channel. I'll be stopping my screen share.
That was a good demo, Shivam. But I have a question. I have a question for you about the test data Priyansh. So, any question? Any reason why you took my name there?
I don't know. You created that table probably, and I just happened to just add that table because there were not many columns in that. I was just testing. So
Okay, I'm glad I was on the screen for a while. Yeah.
cool. It's a really interesting stuff. You guys go ahead and try this out. You'll definitely be amazed with many things.
Yeah, it will be it will make more sense when you actually see the benchmark and stuff and how the data just goes in a flash from point A to point B. With the UI coming in, it will be better. You won't have to just write those lengthy commands and things like that. So just hang in a bit and we'll present a good set of great quality data engineering tool that's also open source, like from India for the world. So great. So we started at around 9 p.m. local time in India, ISTs, and it's around 10. We have just crossed maybe 1 to 2 seconds after past 10. So yeah, it was a great meeting all of you. We thank you, Akash, for your questions, and the Sanskar, Harshvardhan, the folks that joined us, Sayan, and I guess someone joined late as well. But sure, Sandeep has a question. Yeah, sure, Sandeep.
No. Just the issues thing in terms of the number of open issues. I think that you can once remind.
Sure.
Yeah.
So, yeah, it will take just 1 minute time to just show you the issues and how to do that. So we have around 2 to 3 types of repositories. So one is OLake Docs, the front-facing website. So we have some documentation issues over here, like adding for enabling CDC in Aurora or Azure or RDS or MySQL connectors, standalone CDC, the docs for these connectors for Postgres and MySQL, which are yet to be written. And if I go to the OLake side of issues, the main OLake project, yeah, okay, not OLake, this should be OLake. Great. So over here we have some 65 issues. We'll create some more smaller issues. Like append only mode, it's a feature that we need some contributions on. The bug fixes, how you can use a document key instead of ID for some sharded MongoDB instances. So as I talked about previously, just go to first good issues if you are a newcomer. If not, we also have a tag for first, second issue. which is trivial to be used in open source project, but we went ahead with it. So after you're done with
Priyansh, just sorry, one thing I would like to add before
sure,
this.
sure.
So, guys, we are aware that some of our PR reviews have been a little slower, and there were some blockers in terms of the verified commits and all. We are trying to solve all of these blockers, and from the next week onwards, you'll be seeing a lot more faster PR reviews, because we are adding some muscle to the PR reviews, and also adding like some level of priorities on the PR reviews, as well as one quick thing that is going to come up is right now you will see a lot of issues with tag to do. We are going to make sure there's to do issues which are really smaller issues, or some big issues as well, but this will have a proper description as well, because a lot of times these to do issues are created by our CI, which just checks out the to do in your code and it automatically creates a ticket, right? So we are also going to add a lot of like kind of a description, I would say, to all of these, so that you guys can just come and start with like good first issues, good second issues, what Priyansh has recommended, right? And then you can actually move up the ladder. Harshvardhan, again, thanks for you picking up the first mid-level issues. It's a big issue. Looking forward for your contribution.
Great. So yeah, it's a Thursday night, so won't bother you much. It's been already exciting implements. Yeah, same from our side as well. Harshvardhan will continue to ship good features for US and for the data engineering community as well. So yeah, won't take much of your time. Just shout out or send in any questions you have to us over Slack, or you got 1 minute over here to send us question if you have any. Else we'll be just wrapping up with this community session, the fifth OLake community meetup, and we'll be coming with sixth OLake community meetup in maybe a 2 weeks time. The schedules will be over Slack community for you, and from this point on you'll have a regular recurring meetings where even if we don't have anything to show you, we'll just take up your questions, help you set up OLake, talk about how things are going in and going out. Just few 30 minutes meetup every week or maybe bi-weekly. So yeah, just stay tuned over Slack for more. So yeah, I can see Merlin just giving us a bunch of bouquets. Thanks, Merlin, for that. Sure, that was all from my side, and we'll wrap it up. Thank you all for joining in. Thank you, Shubham, for the explanation. Thank you, Akash. Thank for all the OLake team, and we'll see you in a couple of days. Bye-bye.